In this video, we're going to talk about how do you match graphs between the original function and the derivative. So just as in our homework, we're going to start a little simple, and we're going to start with what if our original function is a line, okay? So let's say I have a set of axes here, okay? So this is going to be my function axes, and then over here, I'm going to have this be my derivative, so that way we can compare and contrast. Okay, in our homework they have us do a match game, but the basic idea is that they will give us something like the following picture. Alright, so there's my function. Now, this function is the function of y equals 2x, or f of x equals 2x. And I know that for a couple reasons. One is because I made it up, and my slope is up 2 over 1, right? My slope is up 2 over 1, and my y-intercept is at the origin. So technically, this is f of x equals 2x. Okay, but my question for you is, what is the slope on this line? Is it always the same, or does it change? And of course, it's always the same. This has a slope of 2. Okay, now remember, the derivative is instantaneous slope. So if I asked you what's the slope of this function everywhere, you'd say it's 2 everywhere. What that means then is that the derivative of this function should just be 2. So I'm saying that this has a constant slope always of 2, so this will always look like 2. So that means that if you want to graph the function y equals 2, there we have it. So let me go ahead and pan out a little bit. So that's the original function. It has a constant slope of 2. So the derivative will have a constant value of 2. Derivative will have a constant value of 2, so y equals 2. All right, let's do another one that just has to do with lines. So for this next one that has to do with lines, let's say that we get a little bit crazier. Okay, so I just made this one up, but it appears as if I'm going down 3 and over 1. So this line has a slope of -3. Again, when I'm looking at a line, the slope is always the same. Pretend it's not wiggly. See, there's a little bump in it. But anyway, the slope here is always -3. So the derivative will always have the same value. The derivative of this function will always have the same value, which is -3. So that means that the picture of the derivative will just be y equals -3. So if I come down here to -3, I'll get that picture. All right. Now, in my next video, I'm going to do trickier examples for what happens when functions have bumps in them. So this is an example of just the function is a line. What does the derivative look like? The next one, the function will be a curve. What does the derivative look like?